Hi, everybody. So I hope it's okay. Yeah, my name is Aleksandr Zharkov, and welcome to my session today. Um, Unlike other speakers, a lot of other speakers, I'm not coming from vendor. I'm from the other side, so from the side where we need to do a lot of stuff by our hands. I'm from Heidelberg Materials, so previously in Germany, I think it was known as Heidelberg Cement. What we are doing, simple work, producing construction materials like cement, concrete, and so on. And you may ask, what have you do with containers? Yes, we have different types of containers, but since 2019, we actively use Kubernetes in our work, mainly to deploy backend services for modern applications for our own development. And yeah, I joined Heidelberg Materials also in 2019. Initially as a lead architect, building the API platform, and now we have grown pretty fast. And yeah, I'm head of APIs and platforms, have several teams. And one of the team is a DevOps. And since I was also starting first deployments by myself in our first Kubernetes cluster, yeah, I have pretty good feeling what we are doing. But what I will be talking about today is mostly the result of work of several teams, and especially the DevOps team. So maybe a bit about our landscape. So we have several products developed internally in-house. Some of them are customer-facing, like mobile application to track deliveries. So it's like pizza delivery tracking, but our customers waiting not for pizza, but for concrete, and want to track where is the next truck coming. Then we have created several products for our cement plants, helping us to optimize production plan. Some internal products for dispatchers and drivers. We are deployed in 3 global regions. So it's North America, European region, and Asia and Pacific countries. We have different ERP landscapes behind, so that means APIs need to deal with a lot of external dependencies, external services, and this brings need in a good monitoring and good traceability or observability. From the technologies, we use in front-end web single-page applications created with React.js, and mobile application created with React Native. All of them connecting to the same API platform. Some APIs are more designed for products, and some are shared between several products. On the backend, majority of services are .NET. We have started deploying .NET as container applications from the beginning, thanks to .NET Core. And yeah, there are also some Python services, mostly in the area of data science, in data science teams, where we usually have a different type of load. So in most of cases, it's training models. That's why services require a bit different scaling and have a different metrics to track. In the beginning, we were deploying databases also to the Kubernetes cluster until it was not so much data internal for our internal needs, the big data stored in ERP. But some applications also have very operational data, and with the time, we started using databases as a service from a cloud provider. And yeah, as a cloud provider, we use Microsoft Azure and Google Cloud. Google Cloud just a bit, mostly for API management for APG. So maybe history of our observability evolution, it was evolving together with a team. We started pretty small. like a backend team consisting of 3 developers, including myself. And yeah, there were a bit more front-end developers working on 2 different products, and we started pretty easy. All the live logs were available in pods. At that time, we have used OpenShift console. Sorry, and they were exported as well to the blob storage for the history and for review and audit. And we stored exceptions in self-hosted Sentry instance. Then later, with the team growth, we switched to cross-functional teams and we created a DevOps team. So we already started using backend logs in OpenSearch. And we have introduced application insights for application performance monitoring and correlation between different microservices. And since we extended our Kubernetes usage, we're using Prometheus and Grafana. As well, self-hosted solutions. Then later, it was developed even more. Some cross-functional teams received the DevOps knowledge. They started deploying or doing some DevOps work on their side, but we still have a central DevOps team. We continue storing logs in OpenSearch. We tried a bit Azure logs, log analytics, but it looks like a bit expensive. Then continue using Prometheus and Grafana for infrastructure, and we have alerts in Azure and in Grafana. Alerts are managed as a code, and different Azure workbooks with current application state description, they were created directly by the teams themselves. And this year we have almost the same state. The difference is we started transition to Grafana as our central tool for monitoring and alerting. Why? There is a set of challenges with current setup, or with previous setup already, I would say, for development teams and for DevOps teams. So development teams very often do not have deep understanding about operating infrastructure, what is behind one or other dashboard which we have in infrastructure in Grafana. Another challenge is sharing access to workbooks, because that's a limitation of Azure workbooks. When you create workbook and want to share it, you need to share as well access to the raw data, and very often it's not a good idea when you want to share, I don't know, with completely non-technical people some metrics of your application. It's a bad idea to grant access to the whole application insights resource. For DevOps team, it's similar challenge, since there is right now more than 10 product teams, DevOps engineers who started on call who started on call support. They usually don't have enough knowledge about application, which parts of infrastructure they need to correlate to some application parts. And in screenshot, you can see it's about 100 workbooks used currently. And for DevOps team, it's not so visible what to do, where to check, which workbook to check to understand if application running well or not during on-call hours, for example. What we want to achieve, we want to have one place to retrieve application status. We want to have an easy way to share dashboards with other teams, with management and, I don't know, stakeholders. For us, stakeholders is usually business, so not the end users, but business, and we want to keep possibility for developers to create dashboards by themselves, so that they are not much dependent on DevOps in this case. And we want to achieve as well knowledge sharing during our development. So not only sharing knowledge about infrastructure to developers, but vice versa as well, sharing knowledge about application to our DevOps team. And one also important part, we want to have possibility to create some dashboards with limited access, because in some cases we still have a sensitive data about infrastructure or about application which we don't want to share with everybody, and we want to have this limited access. So what is our solution? We decided that Grafana will be our place, at least for now. Let's see how it will evolve. How to achieve this? First of all, we started with connecting different data sources which we are using. That's Prometheus, first of all, for infrastructure. Infrastructure part, that's OpenSearch logs. So for cases when there is not enough information for development team in application sites, in metrics, or in Prometheus, they sometimes use extended information with logs, and we keep capability to create queries to our OpenSearch from Grafana. Then another part is Azure Monitor for cloud infrastructure, like database services or Azure functions or some serverless stuff and other topics. Of course, application insights. In application insights, we are using mostly metrics for the applications, so it's a correlation of different calls. We also use some custom events for two purposes. One purpose is to save signals about some business events, like simple example, user clicks on user interface and we want to save this information, but we also use custom events, for example, to check or to save the status of different stages of ETL pipelines, for example. And we as well use Azure Data Explorer, so it's basically the database engine which is used behind the application insights. And it's pretty good for storing events, different types of historical events, and we currently use it for some additional metadata and custom metrics like delivery metrics, so the metrics which we save during development process. Access control. So we decided to start relatively simple way. So the first decision is that we share majority of our dashboards in the one public organization, which is available for everybody with Active Directory access who can access the Grafana itself. Then we have a set of organizations inside Grafana which are mainly intended for development purposes. So we split it into two parts, like production part, production dashboards, which are ready to use in daily operations. And the second part is development dashboards or development organizations where our developers can create dashboards, experiment. They have access to the same data sources, but we limit this access to these development organizations only by the team, so that team can have safety during development process and just do what they want, and when ready, start using some dashboard as production. And one more decision is to manage all the production dashboards as a code. So that means you can do development of a dashboard whatever you want. You can use a user interface, you can directly write JSON. But if you want to put your dashboard to production state, to being used in production, you need to create a merge request and put it as a code to the Git repository. We have had a lot of discussions with teams how we want to organize dashboards. Current challenge, we have separate list of infrastructure dashboards, which are just showing status of specific cluster or status of specific resource groups. I don't know, GitLab, pipeline status, and so on. But that's not so easy to navigate and not so easy to understand for developers what to use. At the same time, I think 2 or 3 years ago, we started an interesting initiative. We created a product feature model, which basically is a tree hierarchical, which is a tree showing all the features for specific product. Usually it's two or three levels you can see on screenshot. So it's currently maintained in Jira as a structure. And almost every user story is currently connected to specific feature in this product feature model. At the same time, we have feedback from GitLab pipelines when we finish deployment. To specific stage, we update Jira component that it was released to specific version. Yeah, we have new version which is deployed, and every user story has connection to the set of components and to the set of features. And here you can find a correlation between components deployed and the features which we have. And we decided to organize our dashboard using this abstraction. Take, let's say, two highest levels of the product feature model. Here you have example of one of the products called Data Link, so API as a product, and it has one feature, development portal, and development portal have a subset of features inside, like user management or API references or developer success and so on. So, and we decided to organize all the services in this way. Let's say if we add a set of microservices which are related to the user management, all the services will be under the panel called user management. And in this case, if DevOps team receives a call in the night, I have a specific product not working, they can immediately go to specific panel or dashboard for this product and check which parts of a product are not available. So what types of components we plan to use? Sorry. Mostly it's microservices or different workloads on Kubernetes cluster. They are monitored using Prometheus. Yeah, so it's a status, basically status of a service in the clusters. Then we have web applications. Currently, we use black box exporter also to check availability of specific application and put the metrics to the Prometheus. We have Azure functions or Azure application services as well as databases which are deployed to the cloud, and we use Azure Monitor to get this data. For databases, additionally, we have a Postgres exporter, which delivers additional metrics to the Prometheus. As well, we would like to use custom events, and here you can see example of such usage. So it's a dashboard which shows success of our ETL jobs delivering data from plants to the cloud on different stages. Some data is available, some not available. Yeah, if it's red, that means the state is not so good, not available. Yeah, of course, data is not yet delivered or cannot be delivered because not implemented, for example. So, team collaboration. That was our goal, why we started this journey, so that developer can do a lot by himself. And here is a simple workflow, like developer first creates a dashboard in the dev environment, then reviews the dashboard inside the team. Afterwards, developer can create JSON or export JSON from Grafana. It's available from the user interface by default. And then create a merge request to production dashboard in a specific area of our Grafana deployment in our infrastructure as a code project for Grafana. And DevOps team then can do merge and apply Terraform script and dashboard in production, and it can be used by developer again or by DevOps team. And that's the way how it will continue. Maybe a few words about our deployment. So we host Grafana by ourselves. We deploy it as a Terraform set of Terraform scripts. There are also some tricks with user management because, for example, I don't know how deep you have worked with Grafana. If you register as a user from Active Directory, the user edit into internal state, into database, and our code which delivers or defines the role structure or users who have access to specific dashboards. Our code doesn't know anything about publicly users, so that's mostly available or relevant for public dashboards. And for this, we have some scripts which before each Terraform appliement, they take existing state of a Terraform dashboard, of the users in Grafana. They save it into intermediate state and then create them again after applying of Terraform. Yeah. Maybe next steps, what we are doing. So current idea is to onboard more teams. So we have right now about 3 teams started working. Some of them already delivered the dashboards, and we plan to the end of the year to have almost all development teams working this way. Then we would like to migrate also alerts. Currently, alerts created independently in separate dashboards, and we want to integrate them as well to the same dashboards which are used for monitoring. And as well, we would like to connect more data sources like Google Monitor or Cloud Monitoring API, some delivery metrics from Azure Data Explorer and GitLab API, and Jira to extend also our dashboards with a list of, for example, current relevant incidents which we have in production. And one of the last tasks for us is track the usage of our dashboards. I can say I don't see it as a final product. I think it will be evolving. Maybe we will switch later to something else, but currently we see it as our target and desired product. Thanks a lot. If you have any questions.
Let's see. Do we have, yeah, we have 2 questions. Let me just, showing them. There we go. All right, so the first question is, do you use JSONnet to manage your dashboards as code? If not, what else do you use?
So we use JSONnet in our projects, and not only for this part. We use as well JSONnet for our templates instead of Helm charts, for example. Yeah.
Got it. How did you solve, or did you have problem exporting dashboards to different instances of Grafana?
Yeah, we use only one instance. That's why we have a split of dev and production organization. So basically, for us, stage Grafana is a place where DevOps engineers can play with, and the production Grafana is the only instance which we have.
Got it. We have one last question coming. There we go. All right. In experience, how to prevent teams from continuously reinventing the wheel? Tough question.
Yes. So our way here is, from one side, teams will be definitely trying to reinvent the wheel, but from other side, the developers are lazy, and we chosen the approach when we first teams creating templates, and we share knowledge about these templates, and probability that other teams will reuse it very high.
Got it. It's very interesting because questions are coming up at a good pace. Did you implement GitOps with dashboards? How did you do it?
Yes. So as I said, I may even show it, but okay. So dashboards are part of the same repository as Grafana itself, Grafana deployment itself, and when Terraform code applied, it applies also the content of dashboards.
Got it. So basically all Git based.
Yeah. So everything is in Git. Yeah.
How are you managing data storage time? Some data should be held for longer times than others.
It's not completely related, but yeah.
There's 2 questions in one. Yeah.
Yeah, we first of all, we have different data retention time for infrastructure data. It's short living. Usually, it's like all the metrics in Prometheus, like 2 weeks, not more than 2 weeks. Then for logs, we have a different retention. So basically, retention is managed on the source level. And we are playing constantly with retention to save a bit money and have a bit more information. Yeah, so it's not constant.
Yeah, it's not always easy. The one last questions we have: how easy was it to do dashboards as code with Grafana for you? I guess the question is more like, how did you manage all these dashboards in the GitOps way?
Yeah, so the one understanding from our side was that it's not easy to create a dashboard from the zero. We tried to do this, it doesn't fly. And we decided, okay, we start using Grafana as user interface to create dashboard, then export as a code, and afterwards put it to Git repository. And here, the biggest challenge which we see is a code review. It's currently not so friendly to the JSON file, yeah, you can imagine. not so easy to read, and that's currently the biggest challenge which we see in the current setup. But the GitOps itself, it's pretty easy. So it's just additional content deployed together with Grafana to the Kubernetes.
Awesome. We have a few minutes left. Is there any question in the audience? Like someone want to have one last question? Raise your hand. We won't bite. We're friends. 3, 2, 1. Okay, got it. Thank you very much for your talk.
Thanks,
a big round of
everybody.
applause. And again, please rate all the talks for us. It will be very easy and useful.